Hey everyone, hope you're all doing well. In this tutorial, we'll be implementing various 2D wall mechanics, including wall sliding using physics and animations, wall popping with vector reflection, and wall jumping by adjusting the character's velocity. Additionally, we'll set up wall climbing with animations and develop an automatic ledge grab when the player reaches the edge while climbing. There's a lot to cover, so let's dive in. Let me start by explaining the environment I have set up. I am using a free tile map asset from the asset store, and I have prepared some walls for us to test the various mechanics we will implement. You can simply use the default sprites to follow along. I have also attached a box collider to each wall, as we will be using raycasts to detect walls in front of the player. For the player controller, you can use your own script. As always, we will implement the wall mechanics in a separate script to ensure it doesn't interfere with your movement code. However, if you'd like to use my script, you can refer back to the dash mechanic video, where you'll find all the related scripts in the description. To get started, create a new script called wall mechanics, attach it to the player game object, and open it up. Instead of breaking down each variable individually, which would take a lot of time and might not provide a full understanding of their purpose, I'll go straight into explaining the core logic. This approach will make everything much clearer. Also, I'll include the full script in the description, so don't worry about memorizing every detail, just focus on grasping the logic. The first thing we need is a way to detect whether the player is approaching a wall. For this, we use the wall check function, which relies on a raycast to determine if there is a wall in front of the player. To ensure that the raycast does not mistakenly detect the player's own collider, we start by setting the query start in colliders to false. This prevents the ray from immediately hitting the player's body and returning incorrect results. Once that's done, a ray is cast from the player's position in the direction he is facing. The direction is determined by calling getPlayerDirection, a function that checks whether the player is moving left or right. To fine-tune how the raycast behaves, we adjust several parameters. The wall ray Y offset value offsets the starting position of the ray along the vertical axis, which helps prevent incorrect detections, especially when multiple raycasts are used. The wall ray length determines how far the ray extends, making sure it doesn't detect objects too far from the player. The wall check layer acts as a filter, ensuring that the raycast only detects valid wall objects and ignores everything else. Once the raycast is fired, it returns a raycast hit 2D object, which contains information about whatever it has hit. If the ray successfully detects a wall, we can use this information to determine the position of the wall and its normal direction. This detection system serves as the foundation for all the wall-related mechanics. Most of the logic for handling wall mechanics is managed inside the wall mechanics handler function, so let's go through how it works. This function is responsible for managing all player interactions with walls, including sliding, jumping, and popping. Right from the start, we check whether a wall is detected in front of the player. If no wall is found or if the player is standing on the ground, we reset all relevant states. This includes setting is wall sliding to false, ensuring that can wall jump is also disabled to prevent the player from jumping off a wall, and resetting the pop of wall flag, which controls whether the player can perform the pop off wall mechanic. After resetting these values, we simply exit. Resetting these variables is crucial for keeping the mechanics consistent. When the player interacts with a wall, different flags are activated to allow specific actions like sliding, jumping, or popping. However, once the action is complete, these flags must be reset to prevent unintended behavior. The player should only be able to perform these mechanics when they are actively approaching a wall again. The first wall mechanic we are going to implement is wall sliding. At this point, we already know that the player is in contact with a wall, but how do we actually enable the wall sliding mechanic? If the player is moving downward, meaning the velocity is decreasing, and he is pressing the horizontal direction toward the wall, we set the is-wall sliding flag to true. This indicates that the player can slide against the wall from this frame onward, until they either touch the ground or move away from the wall. To make the player slide, we simply adjust his vertical velocity based on the wall sliding speed value, which is a float that we can tweak in the Unity editor. I will show you the values I chose for my character later, but of course, you should experiment with these settings to find what works best for your own character. The clamp method is used to ensure that the player's downward speed doesn't exceed the maximum limit, preventing an uncontrolled free fall while sliding. Here, we are modifying the linear velocity of the rigid body directly. In most cases, it's better to use the add force method because it results in more realistic physics behavior. However, in this case, I found that modifying the velocity directly produces a smoother and more controlled result, especially when combined with animations. Since we are directly changing the rigid body's velocity, we shouldn't update it every physics step. Instead, it's best to modify it within the update loop, which is exactly what we're doing here. This approach ensures that the movement remains responsive and consistent with the animation system. That said, you are encouraged to experiment with the add force method and see the difference for yourself. Keep in mind that using add force will require adjusting the code to account for force accumulation and physics simulation behavior. While the player is sliding, we need to account for the possibility of performing a wall jump. To handle this, we use an integer variable to determine the jump direction. By default, this variable is set to 1, which represents the right direction since the player initially faces right. When the player is sliding, we update this variable so that the jump direction is set opposite to the player's current direction. This ensures that if the player decides to jump, he will be launched correctly away from the wall. If the jump button is pressed and wall jumping is allowed, we enable the mechanic by setting the can wall jump flag to true. The allow wall jumping flag provides flexibility during testing, allowing us to enable or disable specific mechanics like wall jumping or wall popping independently. If wall jumping is disabled, for example, we can still keep other mechanics active. If the jump button isn't pressed while sliding, we set the popped of wall flag to true, which prepares the player for the pop of wall mechanic instead. If the player presses the jump button while sliding, we enable can wall jump and immediately stop the sliding motion. Once can wall jump is set to true, we call the wall jump handler function, which takes care of executing the wall jump. If the player does not press the jump button but wall popping is allowed, as indicated by the allow wall popping flag, we proceed to handle the pop of wall mechanic instead. To execute the wall pop, we call the pop of wall handler function, but only after performing a few essential checks. First, if the player presses the jump button again during this time, wall popping should be cancelled and a wall jump should take place instead. Additionally, we ensure that the player is not currently performing a wall slide and has not already popped off the wall. This is managed using the popped of wall flag, which prevents the mechanic from being triggered multiple times in a row. Now let's break down the logic behind both functions, starting with the wall jumping mechanic. To execute the jump, we update the player's velocity in the opposite direction of the horizontal input. This adjustment is only necessary along the x-axis, where we multiply it by the x component of the wall jump velocity vector. For the y-axis, we set the velocity directly using the corresponding value from the wall jump velocity vector. All these values will be fine-tuned in the inspector shortly. At this point, the player successfully jumps off the wall from a logical perspective, but visually, the character still needs to be flipped to face the correct direction. To achieve this, we call the flip character function, but only after confirming that the player's new direction differs from the previous one. For the pop-off wall mechanic, we execute it by pushing the player away from the wall using vector reflection. We calculate the reflected vector using the built-in reflect method, which takes two parameters. The first is the incoming direction vector, which we construct using the player's movement direction with a slight offset on the vertical axis to improve the overall effect. The second parameter is the surface normal, which we retrieve from the wall raycast using the wall check function. If you're unfamiliar with vector reflection, I've already created a video explaining the concept in detail, and I'll provide a link in the description below. Finally, we apply an impulse force in the calculated direction, controlled by the variable pop of wall instant force. This force should be fine-tuned to create a subtle effect, but for the purpose of this tutorial, I'll set it to a relatively high value so we can clearly observe the results, which we'll test shortly. Now let's call the wall mechanics handler function inside the update method and return to the editor to test our progress. As I mentioned earlier, the wall jumping direction is initially set to 1 by default, which indicates movement to the right. Before we run the test, let me walk you through the animator setup. We only need animations for wall sliding and climbing. For now, we'll focus on the wall sliding animation and leave the climbing animations for later. I'll explain why I use two animation clips in a moment. The wall sliding animation is a simple clip that plays whenever the wall slide flag is set to true. Managing the transition depends on your specific setup. You might have just an idle and run state, or a more complex structure. In my case, I have a locomotion state that includes both idle and run animations. I want to transition from either of these states into the wall slide state whenever the wall slide flag is activated. Additionally, I also want to transition from the falling state to wall sliding. This ensures that if the player runs toward a wall and then jumps onto it, the animation smoothly switches from falling to wall sliding. Finally, when the wall sliding action ends, the animation should transition back to idle. This happens either when the player switches direction while sliding or when they touch the ground. Ensure that each wall is assigned a unique layer, and let's go over some of the key variables that need configuration. The wall ray length should be slightly longer than the character's collider bounds to maintain realistic animations. I have set the vertical offset to 0.05, though you can leave it at 0 if you're not using multiple ray casts in the same direction. We'll address all variables related to wall climbing and edge detection later. I have enabled both wall jumping and wall popping in addition to wall sliding, which is on by default. Lastly, I've set the various forces to higher than usual values so that we can clearly observe the mechanics in action. You should experiment with these values to find the best fit for your character and game. Now let's hit run and see how everything works. Let's start by testing the wall popping. I approach the wall and press the jump button, or alternatively, I can jump toward the wall without pressing any other button. The character is pushed in the reflected direction, just as expected. Now, let's try wall sliding. Notice how smoothly the transition to the slide animation happens, along with the synchronization between the animation and physics. Finally, let's test the wall jumping. Everything works perfectly. The character flips correctly based on the jump direction, and the transition from the slide animation back to the jump animation is seamless. Now let's discuss wall climbing and the auto ledge mechanic. We'll start with the animation setup. For climbing, we'll add 2 separate animation clips. The first one represents the climb start state, and the second represents the actual climbing action. The climb start clip will play as soon as the player presses the climb button while in contact with the wall, regardless of the player's current state, whether idle, falling, or sliding. The climbing animation will play when the player moves up or down while still in contact with the wall. To control these 2 states, we use 2 flags. The climb start flag, which gets set when the player presses the climb button while in contact with the wall, and the climb flag, which gets set when the player moves up or down while continuing to press the climb button. Once you see the code, everything will make more sense. We will create a separate function for the wall climbing mechanic and call it in the update method. This function will handle both climbing movement and also call the ledge grabbing function. To start, we enable climbing when the player holds the climb button. Then we will handle the player's vertical movement based on their input, manage the animations, and finally call the ledge auto function to handle ledge grabbing automatically. We begin by performing some checks to ensure the mechanic is allowed and valid. If wall climbing is disabled, we simply exit the function. Similarly, if no wall is detected, we stop the climbing action by resetting the isWallClimbing flag to false, stopping the animations by setting both parameters in the animation window to false, and resetting the wall climbing input as a safety measure before exiting the function. If a wall is detected and the player is holding the climbing button, we begin the climbing logic. First, we call the ledge auto function to handle ledge grabbing, which we'll explore shortly. We then check if the player was in the sliding state when he pressed the climbing button, and if so, we stop wall sliding. Next, we trigger the climb start animation. As mentioned earlier, this animation starts the first frame of the climb sequence and transitions the character into the climbing mechanic. However, the actual climbing animation won't play until the player starts moving up or down, ensuring a smooth and visually appealing transition. While testing this, I noticed that wall popping would occur if the player held the climb button and released it before completing the climb. To prevent this, I set the popped of wall flag to false, which forces the stop of any wall pop while climbing. Then, we set the isWallClimbing flag to true to indicate that the climbing has started. During the climb, gravity should not affect the player, so we set the gravity to 0. Also, I forgot to mention earlier that I have a separate script handling all the input, but you don't have to implement this. If you'd like, I can leave the scripts in the description for reference. At this point, the player is in climbing mode, but we still need to implement the actual climbing movement. We want the player to move up or down based on vertical input. To do this, we check the player's vertical input against a threshold value, like 0.05, which helps prevent slight movements from triggering climbing. If the player moves up or down, we trigger the climbing animation and then update the player's velocity along the y-axis according to the value set in the wall climbing speed variable. To ensure smooth movement, we interpolate the climbing speed over time using a smoothing function. The ease function implements an exponential decay, which creates a natural easing effect for the climbing speed, making the movement more fluid. If the player stops moving, we halt all movement and transition back to the climb start state. If the player changes direction while climbing, we interpret this as an intention to stop climbing and land. So we stop all climbing actions and reset gravity to its original value. Finally, if the player releases the climbing input, we disable both the climbing animations and mechanics. Now let's look at the ledge auto logic. In this function, we manage automatic ledge grabbing using another ray cast, which is positioned slightly above the wall check ray. This extra ray checks for a ledge. Here's the basic check we need to perform. If a wall is detected but no ledge collider is found, it means the player has reached the end of the platform. In this case, we need to trigger the ledge grab. To briefly summarize the process, when the player reaches the edge of the platform, we will move the player from his current position to the top of the platform, effectively grabbing the ledge. First, we calculate the necessary height to move the player. We use the wall ledge raise Y offset, which is already positioned above the platform, but we add a small value to prevent the player from clipping through the platform. This adjustment makes it look as though the player has jumped up to grab the ledge, which you'll see in action shortly. This calculated height represents the y-axis movement, but we also need to calculate the x-axis value to create a 2D vector for the target position. The x-axis value corresponds to the width of the platform. To find this, we first obtain a reference to the hit object's position, which represents the platform's position, from the hit information returned by the wall check function. This position is in world space, but we need to calculate everything relative to the character's position, so we convert the hit position to local space. Then, we calculate the width of the platform by dividing the x-axis value of the hit object's local position by half. Next, we determine the target position based on the player's direction. If the player is facing right, we keep the calculated values as they are. However, if the player is facing left, we invert the x component. Finally, we move the player to this new position to simulate the ledge grabbing action. Now let's go back to the editor and test the functionality. In the editor, I have set the wall ledge ray Y offset to 0.2 and the max height to 1, enabled wall climbing, and set the speed to 20. As always, it's recommended to test different values to find the best setup for your character and game. As I approach the wall and hold the climb button, you can see that the animation transitions to the climb start state. When I move up, the climbing cycle animation plays, and as the character reaches the end of the platform, the auto ledge grabbing occurs. The climbing animations might be a bit fast, so we could consider slowing them down. Also, notice how the animations transition smoothly from wall sliding to climbing, which can be a bit tricky to implement, but I'll show you the solution in the animator window. If the player is in the wall sliding state and releases the movement input, the animation will transition correctly to the idle state. However, if the player switches to climbing while sliding, we need to transition directly from the wall slide to the wall climb state. This presents a challenge because the usual animation transition would try to go through idle first, causing a disruption. Let me show you how this can be resolved. First, let's focus on the transition from the wall slide to the climb start animation. This transition happens when the wall slide is false and the climb start is set to true. Next, let's select the wall slide state. In the inspector, under transitions, you'll see two transitions, one to the idle state and one to the climb start state. By default, these transitions are reversed, so it's important to switch their order. The transition to the climb start should take precedence over the one to idle. Otherwise, the animations will always transition to idle because it would have higher priority, which isn't the desired behavior. And there you have it. We've successfully implemented a range of wall mechanics, including wall sliding, popping, wall jumping, wall climbing, and a simple auto ledge grab. That wraps up the tutorial. Thank you for watching, and I'll see you soon. Goodbye.